So welcome to Black Hat. Thank you for showing up at 9 a.m. for what I expected not many people would be. So I'm actually excited that there's so many people here. So we don't have much time, so I'll just get right into what we're going to be talking about. So here's kind of an overview of what I want to go over today with you guys. Really talking about what is the problem that my research is trying to address. Who is the bro? What is the ELK? How you can really beef up your ELK to get more information and context out of it. How you can make your ELK a little bit more intelligent and get that extra information out of it. Bringing it all together, visualizing it with Kibana. And then I'll be introducing a open source framework that we're releasing this week in Black Hat to kind of tie in all this information together. Ooh, wrong way. So real quick, a little bit about me. I'm a lumberjack and I'm okay. What this really means, right? Any Monty Python fans? I've been in the security industry for 10 years. A lot of that has been with logging products. So I have a lot of experience looking at logs and trying to get the right information out of it. Currently, I do security research at Tripwire up in Portland, Oregon. So I get to spend a lot of my time just playing with fun tools like Bro now. So here's just kind of a simple visualization of a typical security architecture. You're going to start in the middle, at the very center core, doing simple things like maybe firewalls. Maybe you guys have heard of antivirus. You can start with that. And then get into a little bit more complex things like configuration management, change management, and then really where a lot of the information is, it's not on assets, but on the actual wire. So you want to get into things like network security intelligence and network security monitoring. But doing this and analyzing this is a lot of data. And with a lot of data, you have to store that data, which increases costs. And with the increased costs and all that data that you're looking at, increases complexity in how you store the data, how you get the data out of it, and actually get useful information out of it. So right now, a typical logging product that a lot of people use, you're just getting the tip of the iceberg. So you're collecting things like logs, stats, alerts, and that's really just the tip of the iceberg. The problem with this is that you're at the mercy of, one, the developers who wrote the software, what they deemed worthy to actually log. And then the next point, you're at the mercy of who implemented your logging solution. And are they collecting the right logs? Are they storing them long enough? So, it's just the tip of the iceberg of what we can actually collect. You can start tying some systems, different packets together, get session data, but it's still really not where the core of the information is. Once you tie this information together, you can start building packet strings, do some, as traditional intrusion detection. But really, where the core of that data is analyzing your full packet capture. That's where the real meat is. So, what do we do with this information? How do we get it out of it? So, here's if anybody that's looked at a live packet capture. It's really exciting looking at a console. What does this information do? What do we get of it? We can feed that data through something like Bro. Bro is an open source intrusion detection system, and they market themselves as a network security monitoring tool. So what that means is they'll inspect the traffic in real time and be able to pull out the actual OSI layer traffic from all the way from 1 all the way up to 7. So what that means is that we can look at things like the SSL traffic, pull out the certificates, make sure they're valid, make sure nobody's abusing the protocols, do things like inspecting SMTP traffic, pulling out email addresses, who's sending email in and out of your environment. And then your typical IDS type things like looking for signature-based attacks. It also does cool things like SEM correlation, looking for brute force attacks. But what I really like about Bro is that not only does it in real time, is that you can feed it packet capture data that you've collected elsewhere. So you can use it for a forensics analysis and get really cool information out of it. So, I can actually back up a little bit. So as it does all this, it writes it all to a log file. So you can see a list of some of the sample log files that we have here. And Splunk, Tripwire Log Center, there's a lot of them out there. A really cool open source one is called Logstash, and they have probably one of the best logos for a logging product.
So the way Logstash works is first, you're going to collect it with an input. Here's a few sample inputs that they have. They have over 40 inputs that are really nice. Things like a TCP or UDP collector for things like syslog. They'll collect local files. You can actually interact with it if you're on the console doing things, just feeding it log data manually. They have things like Lumberjack, which is a file collector to send data from remote systems. So when you get that data in, you're going to do some filtering on it. So this is the core of the normalization is they call it grokking, which is pretty interesting. the normalization of pulling out the valuable metadata from logs, the who, the what, the when, the where, the why, maybe. Getting things like IP addresses and ports and all that good stuff. They do some cool things like GeoIP, so you can see who and where traffic is going to in and out of your network. And the really nice one that I like is the Translate, which is one of their community plugins, which allows you to really enhance the data to our advantage. And I'll get into that a little bit later. Then you got to put that data somewhere. So what they call the ELK stack is Elasticsearch, Logstash, and Kibana. So they were really tied into the Elasticsearch core. But they also do things like forward to syslog. They'll write to other traditional relational databases, email, PagerDuty. They have quite a few different outputs that you can send to. So I highly recommend you kind of look into what they have, so they can probably integrate into your existing tool set pretty well. So what do we got to do? So it's not just a one-time shot. We can use many of these. So you can do things like TCP collector, send it through quite a few different filters, and then output it to multiple different places, like Elasticsearch, and when show it to standard out to make sure you're getting that right information. So you can really mix and match and play with the ones that are to your advantage. And you get something that looks like this. This is Kibana. So you can start visualizing cool things and look up IP addresses and ports and do histograms and show anomalies of traffic. So we can see here there might have been a weird anomaly right in the middle of the day. So it's a lot of information, and you might do some anomaly detection by looking at it, but it doesn't really mean much, right? It's a lot of information, and you need context on how you do that. So what do we want to use to do that is something that is similar to threat intelligence. And there's quite a few different ways we can do it, but there's a really cool one with Bro. Oh, let me I'm jumping ahead. So with all that data it's a lot of information, and it's really drinking from the fire hose. One of my coworkers told me an analogy is that it's like finding a needle in a stack of needles, right? And it's the security data that you're getting it's becoming more than just big data. It's morbidly obese data. So right, chocolate. But there is a way we can get around this and solve this problem, and that's with threat intelligence. So there's a company called Critical Stack, and they are a free online service. You just go in, you log in, create an account, and it's a point-and-click integration with threat intelligent feeds that are out there. So you can just sign up for their things and just choose, I want to know about command and control servers, or I want to know about Tor exit node IP addresses, or maybe file hashes, or maybe I want to look at malicious domains that are hosting the Zeus malware. There's quite a few of them. You just install their agent, and it aggregates all this information, can pull it together, it writes it into what is known as Bro code. So it writes it so Bro can read this information, pulls from over 100 different threat feeds now, because this is a little bit dated, and they're getting close to having over 1 million indicators of compromise. So as your data is looking at this in real time, you can reference threat intelligence and be able to know if the information coming in and out of your environment is malicious, or they're malicious file hashes, things like that. It's really cool. The value is also with this is if you are collecting packet capture data, you can reference threat intelligence in a forensics manner. But we can also do similar threat intelligence with Logstash, right? So we can get into using the custom filters, then the Grok message filtering, get the really cool information out, add custom fields to really add metadata to that the logs that are coming in to give you additional context. Do things like GeoIP, date matching, and the really cool one is using the Translate plugin. So it's just not just a high level of hey, this is what you've got to do. We can really put on your nerd glasses and nerd out with me as we look at some code here. So this is what a typical Logstash normalization rule looks like as it ships out of the box. So this is going to normalize an Apache log. So you can pull out things like the IP address and put it into the client field, or you pull out something that looks like a word, put it into the method column, and so on and so forth. But it's a lot of information, which is cool for when you're just doing and getting a proof of concept up. But as you start deploying this configuration file is going to get very messy very quickly. So what I like to do is utilize custom patterns. So I can take all of that regex and code and throw it into a custom pattern directory, create a different rule file for each one of my devices that I'm normalizing, and then just create a rule ID for each one of those messages that I'm normalizing. So then I can just reference a rule ID in the configuration file, and it makes it really clean to look at and really simple. But there's additional data that we can use this for. It's not just for cleaning up a configuration file. What we can do is just add conditional filtering off of this, so we can start looking at what message is actually coming in. So, by referencing the regex of what the message looks like. So it looks confusing, but as you get going, what you got to do is just remove your capture groups from your configuration file, and then just throw that data up into your conditional regex filtering. So, not very interesting. What this allows us to do is use the add field functionality in Logstash. So we can do things like add metadata to the information, do things like CEE tags, adding action, object, and status, which may not be in the log message, but we can infer from it. But what I like to do with it is add a rule ID to it, which not necessarily will give you security context, but it cleans up the operational performance of Logstash. So Logstash is a top-down normalization engine. So it's going to go through from the top and start hitting all of your regex rules. So if the rules that you're using are at the bottom of your configuration file, you're wasting precious cycles to try to get that regular expressions. So you can run continual reports for your most commonly used rule IDs, and then just bubble those up to the top of your configuration file, and now your Logstash is performing A-OK. You can do things like GeoIP. They ship out of the box with the ELK stack with GeoIP templates that you can get up and running. The problem is they only give you one. When you get things like a source IP and a destination IP, you got to pick and choose. So what you got to do is just kind of massage the templates a little bit and get it to be able to normalize and GeoIP the information that you really care about. So how do we do that? You can pull it out of we pull it out of Elasticsearch. So here's a very simple query. You run from the command line, and it dumps out the template that is currently being used by Logstash. And you can just copy and replace what you want to use. You just take the GeoIP field that it does, and then just add more of them. So you can do things like your source IP address, your destination IP addresses, proxy addresses, so on and so forth. There's no limit to how many you can use. And then just another simple command line, pop up the template, and you're good to go, off and running. So date match is an interesting one. So it doesn't seem like it would be very interesting as you're collecting data in real time, because the data that's coming in is going to get logged with that timestamp as you collect it. Where this is valuable is when you're doing the Bro packet capture analysis, because Bro is going to look at the timestamp from your packet captures and throw that into the log message. So what we can do is look at the timestamp from the actual log and use that for the timestamp in the message. So when you feed all your packet capture logs from Bro into Logstash, you're not just getting a huge dump of information, right when you collected the data. You can do it and spread that information over time, so you can see anomalies and kind of see the history of the potential attack that you're looking at. Really valuable. The cool one, though, is threat intelligence. So the threat intelligence is a piece that doesn't really ship with Logstash. You kind of got to massage it and make it do it. So there's the Translate plugin. What the Translate plugin allows you to do, it's a community plugin, doesn't ship with it, so you gotta install it. But it allows us to do lookups of IP addresses or whatever. So in the example here, I'm doing a translation on my destination IP field event, DST IP. I take when it finds a destination IP, it looks up in a YAML file, the torexit.yaml, to see if that exists. If it does, what I do is I just throw the word yes in a field called torexit IP. So now when I go into Kibana, I can just run a quick search of any message that says Tor exit IP equals yes. And this is done for any field. So I can do things like Tor exit IPs and command and control servers, malicious file hashes, known phishing campaigns. There's really no limit to what you can do. You can do up to roughly 2.5 million signatures in each YAML file. That's where I kind of hit my limit, but that was running on a Raspberry Pi, so that might have been because it was on a Raspberry Pi. The cool thing is you can run scripts, collect this data, on a regular basis, normalize it into a YAML file, and Logstash will just re-index that YAML file every 300 seconds, every 5 minutes. So you can configure it if that's too much or too little. But just in real time, you can get this information for you out of threat intelligence. So what does that get us? Here is a standard output of a Logstash message. So this is a Bro message that I normalized using everything that I just talked about. So we got our things like our IP addresses. It's probably a little hard to see. Maybe I can use my mouse. So up here, we got our things like our IP addresses and our ports and all that good stuff. But here's where the valuable data gets out. So we get things like our CEE tags using the add field input or filter. We have our threat intelligence, knowing that this is a Tor exit node IP address or a malicious node IP address. And we get our GeoIP data. So we're really enhancing that data to give it additional context that we may not have had before. So before, when we were looking at Kibana and we just saw a bunch of IP addresses, what does that mean? we can start making it, be a little bit more valuable to us. Throw up geo IP maps and see, all of the malicious IPs that are coming into my network. Who are they talking to? And what are they talking back from? So we can see, on here, maybe your critical asset is this big green pie chart. Maybe that's your internal database, and it's talking to malicious IP addresses. Red flag, right? So you're adding additional context to all of this information. Another input or another visualization of critical stack data. So this is the information that we're getting from critical stack. So instead of just looking at IP addresses, we're building that context around what we know is malicious or what someone is telling us is malicious. So it's all good. We're doing all this stuff in real time, which is excellent, right? We all want real-time detection. But the problem with that is, let's say your assets are talking to an IP address. We check it against our threat intelligence. It says, nope, it's not malicious, we're good to go. You're like, all right, I'm good, I'm safe. An hour later, that's a known malicious IP address or a known file hash. You've already done your real-time analysis. You don't know that you've been owned possibly. This is where our TARDIS framework comes in. So this is a open source tool. You can get it on GitHub. What it's going to do is, well, here's the acronym. Any Doctor Who fans, it's not the actual spaceship that we're doing. But what it's going to do is ingest IOC data. So that's things like sticks or Yara, being able to look at Cybox observables, things like file hashes, IP addresses, but also look at a vulnerability scan data. So we can tell you if this is a known, from your threat intelligence, known malicious IP addresses, known, file hashes, things like that. But we can also build more complex stuff using, the sticks format from MITRE. So we can build things like, we know what this shell shock vulnerability looks like. Let's go search for it. So you can take your vulnerability scan data, feed it through TARDIS, and be able to know if any of your assets have been exploited. So you can kind of think of it of a Time Lord of all of your forensics log data, right? So instead of just real time, you can go back and look at it, and it's available here. It's on the Tripwire's GitHub page. You can go download it. I will be doing a demo of it at Arsenal a little bit later this afternoon if you're interested in seeing kind of a hands-on of how it works. So I'd highly recommend you can do it. So here's kind of a visualization of how it works. So for example, we're going to take a sticks or a Cybox observable, feed it into our TARDIS framework, search your log repository, whether that's something like TLC, Logstash, Splunk, anything that has an open API that we can call, do searches for remotely, and then just dump all that information out into a database. So, just to wrap up here, 3 key things that I want you to take away from today. Using network security monitoring with log is very powerful. You should definitely look at doing it if you're not doing it already. Using security tools with intelligence, specifically threat intelligence, whatever provider it would be, you should be doing. If somebody knows something is bad, you should be looking in your environment to see if it's there. So you can do that in real time, or you can also do it as a historical analysis. So, like I said, our code is on GitHub. On my GitHub page, the link is up here. There's going to be a few scripts available and tools. So you're going to have things like your bro normalization rules for Logstash, a few scripts to pull threat feed data from the internet and format it into the YAML files so you can get that up and running, and a really cool script that will allow you to analyze a lot of packet capture data and feed it through the bro IDS and pull those log files out intelligently. So that's all I had for you guys today. Open any questions if anybody has them.
What do you use for your packet capture?
You can use anything really. So you can use things like TCP dump, Ethereal, Wireshark, things like that. As long as it's in the normal PCAP format, then you're good to go.
Have you heard of Time Machine?
I have not. Definitely. Anybody else? No? Okay. Well, thank you guys.